Welcome. This is Colleen Doak, professor at St. Ambrose University within the Masters in Public Health program. In this video, I'm just going to show you how to open R, get the script running, and open the data set within the script. The first step is assuming you have R on your computers, and you'll also see some instructions for doing that within the script once I open it. Click to see your list of programs, and it may or may not be in your recently added options. So just in case, scroll all the way down to R, alphabetically R, and the program name is R. And then you have two options. Open the first option, RI386 3.6.0. Some of you may want to experiment with opening the other version, which is a 64-bit version. If it works on your computer, it can be faster, more efficient. However, it doesn't work on all versions of Windows. So I'm starting with the first option, which is accessible for all of you. Click on that first option. And here on the screen, it's going to open into the R program and the R console. So this R console is where you type in anything you want. So you don't have any data yet, but just to give you an idea, it can be used as a calculator. So let's say you want to calculate, you can't use X as your multiplier. Say you want to do a simple function, 3 times 5 is 15. So you can run a function here so long as you know what the commands are for multiplying and dividing. This is just to give you an idea of what you can do within R, apart from the analysis we're going to do within the 2x2 tables and the EpiR part of the program. Now, I'm going to pick up where I left off in the instructional PowerPoint video, which is one of the things you want to do is when you're in the R console, change the directory to where your script and where your data set is located. And in this case, so I'm under File, go under Change Directory. And in this case, I've saved everything under Desktop, so I can simply click on Desktop and click OK. Now the second step is we're going to open that script. So go again under File, and here we're going to go under Open Script, and we're going to have the option Epidemiology R script.R. It's an R script program. This is the title I gave it. If you renamed it, be sure to look for your new name. And if you don't see it, then either it's saved in the wrong directory, and you need to do a new change of directory, or it might not have been saved as an R script file. Click on Open. And here you see on the right side of the screen the full script. And I'm just going to use a toggle function. So there are two views you can do. One is you can have the console and the script itself tiled horizontally. This is what that looks like. Or you can have them tiled vertically so you can see them side by side. I'm going to run these using the vertical option. And so the first thing you need to know is that everything on the left side of the screen can be run as a command. The pound sign, the number sign here, is an indication to R not to run this line. So even if I tried to run this line, it wouldn't read that as code. And so these pound signs are just notes to self or notes to you to explain the steps in the process. So step one was downloading R to your computer. So if you did not do that already and you're watching this before seeing the PowerPoint slides, it means going to the web link here, or if you're in Illinois, Iowa, Western Illinois, or Minnesota, you can go directly to the Iowa Mirror CRAN. That's the R site location that will allow for the fastest download because it's the physically closest spot. The second step was to save the script and data set to the same directory. So if you're opening this, you've already done that. So this is also just reminding you the script should be entitled Epidemiology R script, and the data is entitled epidemiologydata.csv. If you made any changes to the name, or if when you saved it, it attached a parentheses 1 around it, be sure that you change the name so that you can run the program that follows. So the second commented out text are notes about opening and changing the directory. Those are the steps that I just followed. That is to change the directory and then to open the R program. Now here is your first actual code. Now I'm going to click on this line and on the upper icon, so look at the third icon over, it says run line or selection. If you click on that, it's going to run the code for get working directory, or typed in GETWD parentheses. Everything after that is commented out because it has the pound sign after it. So that's just to say that you're checking the working directory to be sure where the R file is looking. So that's just to show you where you're finding it. So in this case, because I indicated the desktop, it's giving me the full directory for the desktop. This is indicating to open your R script, and then now here is step 4, which we're going to follow next, is how you import the data. And here's some notes about what the code means. There is going to be a first word, we're going to call it data 1, and that's a shorthand code, so R will access the data that you're asking it to open. And that data 1 is a shorthand that you refer back to whenever you're using this word. So whenever you're asking R to do something, you can indicate which data to do that with by referring back to data 1. So this will come in handy when we change variable names. We'll go into variables that are within that data set, and so we're going to call that data set data 1. And remember, you can change that data 1 indication, but if you do that, you'll have to replace it in all the commands that follow. So all of these, step 4, that's commented out, so the program will not run that. Now if I click on data 1, this line means we are creating a name called data 1, and we're setting that to equal to a data set. And the first thing in order to get that data set is we're telling the R program, that we're going to read a CSV file. So the read is telling it we're going to read .csv, that's the type of file to look for, in parentheses then with the quotations around the name of the data set, we're telling it to look for a data set within the directory that we've already indicated by changing the directory, called epidemiologydata.csv. And if any of this name has been changed, it's not going to find it unless you match this name to what you have. So you can either change the name within this, or perhaps the easiest way will be to make sure that your file, wherever you've saved it, is saved in this format. Now if you've made the mistake and you saved it as an XLS format, as an Excel data, and not a CSV, it's not going to work. Then there's a comma, and then the next piece of code is just telling, when it's reading that data set, to recognize the first row as being headers or titles for the variables. So it's saying the header is true, and the separator variable is the comma, because it's a comma delimited data set. There's a final piece of code that may or may not matter in this case, and that is to tell R that whenever it encounters a string variable, and that is a variable where the answers are not just 1, 2, 3, 4, 5, but blue, red, orange, and green, that it should not transform those into factors. So if you say strings as factors equals false, it's not going to make changes to your data. If you do not include this code, it will make changes to your data automatically, and when it encounters a variable that it recognizes as a string variable, it's going to replace the blue and the yellow and the orange with numbers like 1, 2, 3, and 4. So this is just to make sure that your data is not going to be changed. So if you click on this line and you hit run the selection, run line or selection, you're not actually going to see any changes. It simply, if it doesn't give an error message, that usually means it worked. But you want to see for sure that it worked. So here below I've given a set of commands that relate to exploring the data. The first one is just commands that relate to giving me the structure of the data. That includes variable names, the types of variables, how many observations, how many variables. Then the next two commands have to do with giving either the next two commands have to do with either giving the first 6 individuals or the last 6 individuals in the data. So if you click on head parentheses data 1, that's going to give you the first 6 individuals in your data set. And if you click on tail data 1, that's going to give you the information, all of the details for the last 6 individuals. Now if you have a lot of variables, this can be a very long output, so you might not want to run this on a larger data set than what we have. At various times in the script, you're going to want to look back and see what the variable names were in case you've forgotten. And because some of these names are confusing, or just to see if a new name appears when you create a new variable, if you either use the command names parentheses data 1 or type this in, you will get the set of variables for your data. So these are all the variables we have in this data set. And then finally, you can give the first piece of information for the entire data set. Now this is 8,000 variables, so it's going to be a lot of output. And then you can also actually go directly into the data and make changes. Now I don't recommend you do this, but in case you need to go into the data, you want to see the numbers directly or the variable names directly, if you go into type in fix parentheses data, or if you click on this line, it will actually pop open your data, and you can even go in and change the variable name if you wanted. Now I don't recommend this, but if you click on a variable name, you can retype or change this name, and it's going to change it when you save your final work at the end. Okay. Now, you have the data set in, and in order to get odds ratios and risk ratios, you're going to have to install an additional package that's available in R, and it's called EpiR. So I'm going to click on this, and you're going to see that it's going to ask you where your nearest location is, called a CRAN mirror. So I'm going to click on this line, and here it's saying secure CRAN mirrors. Okay, where are you? I'm going to scroll down to, in this case, I happen to be in the US. I'm in Davenport, Iowa. So I'm clicking on USA, Iowa. That's my nearest CRAN mirror. If you are in another location, you'll want to select the nearest CRAN mirror that reflects where you are. And I'm clicking on OK here. And now this is adding a package into my R program that will always be there. But in order to run that package, every time I open the script, I'm going to have to access the library for the EpiR package. So the package may be installed, but those commands are only accessible when I call upon them. So I'm always going to run this library EpiR command using the run line or selection. So if in the future you try to run commands from EpiR, and I'll show you what they are further down below, that will only work if you have run this code. Okay, step 1. We're going to run some simple 2x2 tables. And this is going to make use of two variables that we have. One, the first variable in this table that we're creating is the variable related to whether or not they were bullied. And the second variable is whether or not in 2015 they reported having been always blue in the last month, often blue, sometimes blue, or never blue. So I'm going to run this one line at a time and watch while I do that. I'm clicking on Run the line. That means I'm creating a table, and I'm going to call that table tab. Now I'm naming the rows. I'm naming the rows so that some of the negative values are indicated as missing 1, missing 2. I'm just using abbreviations M1, M2, M3, M4. And then for the not bullied indicator, I'm tagging that as not bullied and bullied. In the column, I'm doing the same thing. I'm flagging all of the missing values as M1, 2, and 3. And then we have always, often, sometimes, and never blue in the past month for this variable. So I'm clicking here, I'm clicking here, and now I want to see what the table looks like, and this is the full result of the data. Now you could go back into the original data set and double check these numbers to see if the total number of people reporting being bullied, not bullied, and also the totals on missing values reflect what you see from the original data set. It should work. Okay, now I'm going to move down and I'm just going to show you if you want a summary that you can compare directly against the variables in the original data. Here is the information on being bullied or not bullied. So this is a table just about that data, that variable. And I'm calling it table with an extra B to distinguish it from the table we created above. And that's just giving the numbers, the total numbers of all the possibilities for answers people have given. Okay, so the next step I'm doing is I'm not creating a new variable yet. I'm just showing how you would create odds ratios or risk ratios out of this data by adding up all the numbers. So I'm just going to use R as a calculator. And so I'm going to take bullied as 1 and always depressed as 1. And I'm going to compare being bullied to being always depressed, setting the not being bullied as the no answer. We're going to put that as the second in our 2x2 table, and the always depressed compared to all the answers 2, 3, and 4 being often blue, sometimes blue, or never blue. So if you were to take that broader table comparing the results on bullying to how they answered in terms of whether or not they were blue in the past month, taking out the information from the missing values, when you create a 2x2 table out of that, we're going to need to add up the information for the often, sometimes, and never blue in order to get that information for our comparison. So the first thing is I'm adding the 282, the 2,453, and the 2,623 that combines the often, sometimes, and never blue conditions. And that's adding them up so they would be one category in the not bullied group to be not always depressed. So that number, if you click on this, will give you your total. Then that's having R work as a calculator. The second set of numbers is the 124, 677, and 542, and that's adding up the not always depressed, but within the bullied group. Okay, so the reason why I did this is I need these two numbers in order to create a 2x2 matrix. And as you may recall from your 2x2 matrices, there's a 2x2 table where you always have the indications of yes and no, yes and no. So your yes, yes condition is going to be in your upper left quadrant, and that's the number 28. And your no condition is going to be the lower right quadrant, and that's going to be your 5,358. And in between are what we call our B and our C quadrants. So what we have here is a 2x2 table. That's your matrix. Using the numbers that we have, including the numbers that we had to add up to get the information, and we're adding them in just like you would for a 2x2 table in order A, B, C, and D. So we're creating a crude table, CR, that's the name of the table, as a matrix. And so this is the code for getting a 2x2 matrix. So matrix parentheses C, and then another parentheses with your values for A, B, C, and D in order, again parentheses, comma, the number of rows, or n row, equals 2, and to give it by row is true. So we're asking to sort out the rows, there being 2 rows, and to provide the information by rows. In addition, for the matrix called CR, I'm going to ask for the row names to be indicated as bullied or not bullied, and the column names to be indicated as always blue or not always blue. And then at the end of this, I'm just typing in CR to get that 2x2 table as it appears. And so I'm clicking through, clicking through, clicking through, and clicking through. So this is our 2x2 table. You should be able to see that this 2x2 table reflects both the odds ratio and risk ratio 2x2 tables that we use in epidemiology, and that this table also reflects the information that you see above. Now here's where we're going to make use of the library, the Epi library, the package that we installed, and this command is going to give us our information for risk ratios and odds ratios and confidence intervals. So I'm going to click here for this line, and here it's telling it to use the method of a cohort count data. So approach it as a longitudinal data set. And here, running that line, epi.2x2, parentheses, CR being the name of the matrix that we just ran, method equals cohort.count. It's giving us our risk ratio, our odds ratio. It's also giving information on attributable risk at the population level and the exposed, and attributable fraction in the exposed and the population. So take a look at this. This is the information that we want to know. So it's saying that for those who were bullied in 1997, they were 1.84 times more likely to have been reported as always blue in the past month in the year 2015. Now the odds ratio is a very slightly stronger association, but it's extremely comparable. So 1.84 only just barely goes up to 1.86. So if you remember the lecture on the relationships between the odds ratio and the risk ratio, there are a number of conditions that if they occur, the odds ratio is a very good approximation of a risk ratio, and this illustrates the point. Now I'm going to do the same thing, but this time I'm going to create a new variable. So you don't have to do all the math. So when you decide you want to revise another variable for your outcome, instead of using 2015, you can use any of the earlier time points. We're going to create a new variable, making use of, first of all, the data for bullied. You're all going to use this as your exposure variable. And then we're going to create another variable for the outcome, which is a yes-no variable. So we're going to create a yes-no variable for the exposure and a yes-no variable for the outcome. And we're going to create these as 1-2 variables so that our 2x2 tables look like they're supposed to look, with the yes-yes condition appearing in the A quadrant and the no-no condition appearing in the D quadrant. So the first line is we're setting a new variable, data1, and the $ is indicating that this is going to be our new variable name, bullied. And we're setting that equal to, within data1, the variable ysaq.518. This is going to just create a variable bullied that's equivalent to the existing variable related to bullied. But we don't want to keep all of that data exactly the same, So what we're going to do is we're going to set all the negative values. So that's where that old variable is less than 0. We're going to set that to be NA, or not applicable. In other words, missing. Then we're going to set all the data which is 0. So the current variable is a 0, 1 variable. We're going to set it to 2, so it puts our rows and columns in the right order. And now we're going to test this new variable against our old variable to be sure that everything has been assigned appropriately. And now we need to assign row names. So that is, we're going to assign the names of bullied and not bullied. So when we read our table, it's going to make some sense. And then finally, we ask for it to show us the table. So this is a table of our original data against our new one being bullied versus not bullied. And so what we see is all of the people who answered bullied as yes are also indicated as having been bullied in this new answer. None of the individuals who indicated missing information are given and are attributed an answer for having been bullied or not bullied. And all of those who answered no or 0 are indicated with our new variable as not bullied. Okay, so it worked. Now I'm creating a new variable, and you can make changes to this to reflect one of the intervening time points that you're interested in. And so the only thing you'll have to change is the variable name that you're going to use here. So I'll just show you how this works. So this is setting a new variable called alwaysBlue to a variable, the original variable where they asked in 2015. So if you change that 0.6 at the end, it's going to reflect a different year. So take a look at your variable names and select which output year you want to look at. So first of all, we're setting alwaysBlue to the original variable. If it's a negative number, it's going to be set to missing. If it's a value of 1, it's going to be set to a yes condition. If it's a value of 2, we're going to set it to 2, meaning no. And so for that reason, the no condition, or not always condition, the number 3 is also going to be set to 2, and the number 4, which is never, is also going to be set to 2. So our conditions, all the conditions that reflect not always being blue are going to be given the 2 condition. And then here we're going to see how it worked. We're going to give the row names of always blue versus not always blue, and we're going to get a table comparing the original variable, which has negative numbers, to our new value. So not always blue is our answers of 2, 3, and 4. The missing values do not appear. Okay. So now we can get crude information. So just like we did above, we took the original variables to get a 2x2 table. Here we're going to skip a step where we don't have to add up all the information anymore because we have variables that are simple yes/no variables. So we're going to get a crude table. I'm not naming it CR, I'm naming it crude this time. And we're going to compare the bullied yes/no answer to always blue yes/no answer. And I'm giving the row names, bullied and not bullied, just to be sure we know where the data is coming from. And the column names, always blue, not always blue. If you don't indicate the row and column names, that's fine, but you simply will just get 4 numbers and you won't be sure what's attached to what. And now we're going to run that 2x2 table by having it give us the information that we've asked for. And there we have our 2x2 table. Now this matches, I'm just going to scroll up. This matches the 2x2 table we calculated above, where there's 28, 1, 3, 4, 3, 28, 1, 3, 4, 3, and then 60, 5, 3, 5, 8, 60, 5, 3, 5, 8. So once again, here we have less code. We didn't have to add up information. We've simply created a new variable and you can create other variables for other endpoints related to always being blue. And now we're going to take the EPI 2x2 table, and instead of CR, we're going to use the data from CRUD. We didn't have to run a matrix because we have a simple 2x2 table where there are only yes/no conditions. And if we run this, it's going to give us the same results as we had before. Okay, so essentially now you know how to get a 2x2 table in R, and including increased risk ratio and odds ratio, as well as additional information that is useful in epidemiology. The next videos. After this, I'll give additional videos to show you how to calculate stratified risk ratios and odds ratios. But this is essentially your starting point for calculating risk ratios and odds ratios.